Let's get this problem set up. So here's my slope, and I'll put it here. The body, the angle is alpha here. That's the angle to the horizontal. Then we need to think about what forces are acting on the body. So first up, there's going to be a weight acting down, 20 G. And with that, inherently comes a normal reaction force that acts perpendicular to the plane. I can put the angle in here. That's also going to be alpha. The reason being is that this angle that I'm now highlighting is going to be 90 minus alpha. And then I could draw a 90-degree angle here, and I can see that, yeah, alpha is also going to be the same as this. Sorry, this angle is also going to be alpha. We're then told that the body's held at rest by the action of a force of magnitude P, and it's acting up the plane. Like that. And the coefficient of friction is lambda. So let's take a look at part A. We're told when P is 100, the body is on the point of sliding down the plane. Now, because clearly we've got, this is a rough plane, we're told that there's a coefficient of friction, then that means if it's about to slide down the plane, there's also friction holding it up. So I can put in a force going this way, opposes motion, and I'm going to call this F capital R. That is the frictional force due to the normal reaction force. So let's have a look at this. We're going to have to apply F equals ma. I think I'm going to go down the plane to start with. Therefore, I'm going to get the component of weight acting down the plane. It's 20g cos alpha perpendicular to the plane. It's 20g sine alpha parallel. You could split the force into a triangle like this. Okay, with this one acting that way away from the plane, and then this is the force I'm interested in. Because it's opposite the angle, that's why it's sine alpha. So 20g sine alpha, then I'm going to be minusing 100 because that is opposing motion, and I'm going to be minusing the force due to friction, and that is going to equal 0. Let's also apply F equals ma perpendicular to the plane. So now I've got that R minus 20g cos alpha is also equal to 0, which means that R is equal to 20g cos alpha. You can, of course, just resolve the forces and say they must be equal, but I've gone for applying F equals ma. I just got into that habit quite recently, actually, so that's fine. Okay, and there's one thing I've not yet done, and that is to use the formula for friction. Fr is always less than or equal to mu r. But because it's on the point of sliding, it's actually going to equal it here. So Fr is going to be 20g times mu times cos alpha. And we're getting there because now we can combine it all together. Therefore, 20g, sorry, I'm going to do this in a different color just to try and um, it all just merges together otherwise. So I'm just going to separate a few things. We've got this here, that there, then we dealt with the friction. Okay, now we bring it all together. 20g sine alpha minus 100 minus 20g mu cos alpha is equal to 0. And I can divide through by 20. That's going to become 5. Then I've got G sine alpha is going to equal 5 plus G mu cos alpha. Okay, they've just written it the other way around, so let me write it the same way as them. Okay, and we're done here. We've got a nice equation relating the angle with the coefficient of friction. So let me just recap. I drew the forces on my diagram very carefully, thinking about all of them and whether they oppose motion or helping it. In part A, I've added these red forces because it's on the pointer sliding down the plane. Then I've applied F equals ma down the plane. You could also just resolve the forces in that direction and set them equal, essentially, the downward forces and the upward forces down the plane. Then F equals ma perpendicular, same sort of idea. We've got the R is equal to 20g cos alpha. Those are the only two forces perpendicular. Get the coefficient of friction involved. Fr equals mu r here. Bring it together. We've got we've got that fr. Oh, sorry, I kind of used this bit in here, and now I'm using this bit in the top bit, and we rearranged to get the formula that we're asked for. Right, in part B, it says P is increased to 150, and then it's on the point of sliding up the plane. Use this and the answer to A, find the acceleration, sorry, alpha in terms of G. Acceleration is still 0. So here's my diagram, but now it's about to move up the plane. So the frictional force is in fact again going to oppose motion. P is now 150. Friction is going to go this way. So we still have that R is still 20g cos alpha, and FR is still 20g mu cos alpha. Okay, so let's apply F equals ma up the plane again. Did I apply it up the plane? I applied it down the plane before, but it didn't really matter. Okay, I'll go with F equals ma up the plane. So now I've got 150 going up the plane, but opposing it is going to be this FR, which is 20g mu cos alpha, and the weight is now negative. I could have stuck with it applying F equals ma down the plane. That might have made sense, but because it's trying to go up the plane, I decided to switch it. It doesn't really matter. Minus 20g sine alpha equals 0. If you switch it, you just get all the signs the other way around. Now, before I go any further, let's just take stock of where we are. So we're trying to work out an expression for alpha in terms of g. It doesn't say mu at all, so we're going to have to try and eliminate mu. And therefore, what if we could basically substitute in for g mu cos alpha? We can start off doing this by dividing by 20. Actually, let me do it in steps. So 20 g mu cos alpha is going to equal 150 minus 20g sine alpha. And now divide through by 20 as before. This becomes 7.5. And this disappears. So now I've got a really useful equation, and I can replace this by 7.5 minus g sine alpha. This is, by the way, this is FR, and actually rewriting it, and the answers they do this, rewriting it as FR makes it a little bit clearer, because it just looks more complicated when you have the G mu cos alpha in there. Because at the end of the day, we basically managed to because they're just equal and opposite forces, we can just cancel them out. Anyway, we're going to get that G sine alpha now is going to equal 7.5 minus g sine alpha plus 5. And therefore, 2g sine alpha is going to be 12.5. So sine alpha is 12.5 over 2g, or if we make it slightly nicer, make them integers, it's going to be 25 over 4g. And therefore, we can work out alpha in terms of g anyway. It's going to be inverse sine of 25 over 4g. It's quite a nice question, a bit technical in places because we're always working in terms of mu, in terms of g, in terms of alpha, but you can see how it all works out. Just be careful with the diagrams, get all your forces on there, resolve, up the plane, perpendicular to the plane. This first result guides us along. The second result, you have to realize that we need to eliminate mu from proceedings. So either write it as f back as fr to get rid of it, or you're just going to have to realize to eliminate this 20g mu cos alpha. Either way, we do that, and then we get to here. Okay, keep going with this mechanics. Well done.